Okay, so this question required us to basically fill a Sudoku grid with the values. Okay, so this function of print board was already given to us. This was the function that was already given to us, in which what it was doing, it was basically iterating through all the values of the grid and printing out each and every value of the grid with a certain color like red and black. Okay, this was the function that was already given to us. Okay. After this, we basically had to make some 3 to 4 functions. One was the make puzzle function, which basically initializes all the values of the grid. Next was the get square, which gets the value of a particular square, not just the value and the row set, the column set, and the basically the region set. Then we had to make a function called move, in which what we had to do was we were given a basically a particular index. At that index, we had to enter a value, and we had to check if that value can be entered at that cell or that index or not. Okay, so that was what this move function is doing. And next we have the fill puzzle function. So this fill puzzle function, this was basically an automation of filling the whole puzzle. What we had to do here was like there were two conditions basically. So we had to basically randomly fill out each and every box of the puzzle till the number of attempts is basically less than n raised to power 4, and three-fourth of the matrix, or we can say 75% of the matrix has been filled. Okay, so two conditions. The first was that the maximum attempts are less than n raised to power 4, where n is the the size of the length of the one size of the grid, and the number of squares filled are less than max squares. The max squares were 75% of the total squares. Okay, so let me go into the explanation of each and every method one by one. So this make puzzle, I guess, was the same that you gave us. Okay, so what this make puzzle was doing, it was just initializing the row set, the column set, and the region set. Okay, so this was almost similar to the one that you gave us. Okay, there was not much of a difference here. Okay. Next is the get square function. So for the get square function, we were just given the row and the column, and what we had to do, we had to basically tell all the tell the value that was there at the row and column, and tell the row set, the column set, and the region set. Okay. So the finding the row set and the column set was pretty easy, because the row set was just puzzle of row sets of row, and the column set was just puzzle of column sets of column. But finding the region set was difficult. Why? Because we were not really sure which indexes should be put in the region sets one, which index should be put in the region sets area, or the region sets index, to find the basically the region corresponding to that row and column. Okay, so for that, so what we can say is that the whole matrix, if it is of size n, then it will be divided by root n of those, right? Okay, so by root n, root n, like the first square, the size of the first square or this first sub matrix inside it, the size will be root n, and the second matrix sub matrix, it will again be root n, and root n. Okay, so hence like what I did was I found the root of the value, the root of the n, or the size of the matrix. Okay, so that I stored in this small n, and then using that small n and that capital N, I basically found out the row region and the column region to which my index row column will be. Okay, so my row comma column will belong to this row region and column region, that is math.floor of row by n and math.floor of column by n. So this is like pretty basic mathematics. You can just write it down on your own yourself, so that you can understand how this row region and column region is found. Okay, so once you find that this row region, column region, then it becomes pretty easy. You just need to go through those indexes, the row region and the column region, and you'll find your value that you need. Okay. Next was the move function. So the move function, what we had to do was we just had to check if we can basically do the given move or not. Okay. So here what I did was I basically had to add this new value at row comma column. Okay, so as instructed in the question, I did the same thing. What I did was I checked three things. The first thing that I checked was whether the new value is in the puzzle of row or not, whether the new value is in the basically the row set or not, whether the new value is in the column set or not, or whether the new value is in the region set or not. Okay, so a new value can be added only and only when it is not in the row set, not in the column set, as well as not in the region set. Okay, so I checked here, if it is there in the row set or column set or the region set, then I won't be adding any value and I'll be returning false. In case it isn't in the row set or column set or the region set, what I'll do is I'll change the value at the board to that new value. I'll add that value to the row set. I'll add that value to the column set, and I'll add that value to the region set. Okay. So again, if I find that yes, that value can be added at that position, so what I'll do is I'll add that value at that position. I'll change the row set. I'll change the column set, and I'll change the region set, and I'll return true. Okay. So this was basically the move function. Then we have the fill puzzle function. So for the fill puzzle function, this was basically like calling this move function again and again with random values passed to it. Okay. So what basically here we are doing is we are firstly finding the random this index one, that will be the row at which we need to add our value. Then we'll find index two, that will be the column at which we need to fill our value. Okay. And then we'll also be like finding the value at which the actual value that we need to fill. Okay. So the row, the column, and the actual value. Okay. Now what I'll do is I'll check if at this row and this column can I add this new value or not, and that will be checked using this move function. Okay. So at index one row and index two column, can we add the new value or not? That for that we have already made a function called move, and we'll check it using the move function. If we can, then I'll increase the number of squares filled by one, and I'll increase the number of attempts also by one. Okay. So I'll basically run this whole while loop till the number of attempts, they become greater than equal to this n raised to power 4, or the number of squares filled, they become greater than equal to 75% of the matrix. Okay. So this is how the fill puzzle function will work. So this was all about all the functions and all the implementations of the functions. If you still have any doubts, you can ask us and I'll explain it to you. Okay. Yeah, that's all. Thank you.